Welcome everybody. We have the seminar today. I think this is the second one that we have this seminar. So actually it's like the second starting of the school. Okay, so well, it's a pleasure to introduce Bruno, even though probably most of you know him because he has come here. This is the third time. He's a visitor professor here at the WIP. Almost every September, so it's kind of very regular. I think I introduced him some other times. He did a master in Porto with Mendes on networks. Then he moved to Atlanta to Emory University, where we met the first time to do the PhD. And after that, he has been in Bloomington and in Northeastern University, doing postdocs in two places. And finally, he found like a permanent location in Aix-Marseille, where he's now a mentor. So he has been working in networks and languages, and actually part of this has been also in collaboration, not with me, but with David. So that's also so good.
And there's also parts with you. The secret parts towards the end. So once again, first of all, thank you all for being here, and of course, Jose, Maxi, Victor, Daniel, etc., for inviting me to come here. Once again, almost a resident at this point. So today I'll talk to you a little bit about language use through the lens of big data, so how we can use these new data sources and these new tools to look at how languages are being used around the world. Please feel free to ask me questions, either during the talk or after. Actually, one of the part with David Sanchez actually started because he came to my office afterwards and asked me a question, and then from that question became a paper. Last year, so hopefully we can keep the trend going. So, as you know, you've probably seen something that looks a little bit like this, and this is basically everything that happens on the internet in 1 minute. And so basically you have in 1 minute, you have hundreds of new accounts on Twitter created, hundreds of thousands of new tweets, you have millions of likes on Facebook, gigabytes and gigabytes of information being downloaded everywhere. You have, of course, many hours of videos being watched on Netflix, tens of thousands of new posts in Tumblr, etc. And every time we do any of these things, somewhere out there on the internet, in the big cloud in the sky, what happened? There is a log somewhere. There is some piece of information that is registered that says this person did this at this time. And what this is doing, basically, what my goal is we can use all of this information and all of these logs that are collected for completely different purposes. They're collected so that all of these tools can actually work, and you can be charged for them, etc. And Dropbox can know how much they should charge you at the end of the month if you have a paying account. But you can also use them to see how people are interacting and how people are behaving and talking to each other, etc. So, of course, there are many social media tools. So this is more or less a simple description of how each of them works. And each of these somehow is capturing a different part of human behavior and how humans interact. Of course, this is about the internet, so everything is revolving around cats, because that's what the internet was created for. And the point is, so okay, in Twitter you announce what you are doing and even where you are doing it, because you're posting many times GPS coordinates. In YouTube you can see what you're watching. On Yelp, where you're going and how you like the food, etc. But again, I mean, each of these somehow provides a unique view and a unique perspective on different things and how we interact. But also through the use of these things, and the more we get used to all of these things, and to using these tools and using Facebook and chatting and all those things, at some point, these things become transparent to us. Right? When I'm chatting on Facebook, I'm not thinking I'm using Facebook, I'm thinking I'm chatting with my friends. So these tools can become in some way transparent, and in some way, after a while, you're not interacting with the tool, you're just interacting with the other person using the tool. And somehow the tool disappears from your perspective, and you stop even seeing it in some way. Of course, this has created many opportunities, many big, huge amounts of information, created new challenges, how to manage all of this data, how to extract information from this, how to get insight. This, of course, has been covered in Science, Nature, The Economist, Time Magazine, Der Spiegel, communication of DCM. So you can see that both the challenges and the opportunities of this type of approach and this type of new data and new challenges has been noticed and being tackled in many different ways by many different people in many different fields. So, of course, my perspective, what I'm interested in is not only using social media, or in my particular case, Twitter, which is what I use most of the time, but also using GPS-enabled smartphones. I mean, people joke with me that I'm always living on the internet and checking my phone and doing things online, but this, in this case, is actually a good thing because it's providing very detailed geolocation information that's telling us, okay, this person is doing this here in this particular place with a resolution of a few meters. Right? So you can actually see where people are when they're doing these things, when they're interacting, when they're typing things, something like that, when they're liking things. So you can search for changes of behavior across time as well, and as well across space. Right? So from country to country, from city to city. And of course, you can also look at the different behaviors and the different perspectives at different resolutions. Right? So you can get the global perspective almost at the continent level, and then you can gradually zoom in until you reach city level, right? Or even neighborhoods and street level. Right? There was even a paper some time ago by Jose looking at the streets and how you could use Twitter to track the streets and where they were and how they were used, etc. Moving on a little bit. Of course, this all depends on people actually using these tools. So here what I'm showing you is a map of Spain with, of course, the Baleares and the Canaries. And what I'm showing you here is basically each light dot, the yellow dot, corresponds to one tweet. And this is data that's been aggregated over the course of over 2 years. So you can see that immediately you recognize the main structure of the main geographical structure of Spain. So here, I mean, the underlying map is the same as here, as Portugal. You just have the outline. But just from the tweets, you can see immediately where the main cities are, where the main highways and connections are, etc. So this means that it's providing a very good view of where people are and where people are moving. So it's giving you so you can immediately get all the structure. No? You seem unconvinced.
No, just looking at the dot that I don't understand.
Where?
Murcia.
I have no idea where Murcia is.
It's too large.
Okay. So we can also use and basically, of course, this all depends on people using smartphones. And smartphones means you need to have money to buy them. So of course, the number of users, and here when I say users, I mean users of GPS-enabled tweets. So someone that posted at least one GPS tweet over the course of our sample, per capita as a function of the GDP, of course, increases. The more money people have, the more likely they are to tweet and to at least have cell phones with GPS. Of course, not surprisingly, number one country is Kuwait because they have a lot of money and there are not that many of them. And Spain somewhere around the top 20 or so. And then and after Kuwait, you have the Netherlands, Brunei, UK, US, Chile, etc. So you have a strong tendency to rich countries associated. So moving on. But now what brought us here, the idea is using language, studying languages. And of course, the traditional way of looking at languages is looking at how people write languages, so books and traditional things. Of course, we're trying to be cool, so we're going to look at languages on Twitter. And they're trying to be more fancy and more fun somehow. So on the internet in general, and this is something I stole from a website. It's just a general internet. And it's clear that there is a huge variability in the a wide range of languages being used. Right? So you have English, of course, is a dominant because everybody uses English, followed by Chinese, Spanish, Arabic, Portuguese, Japanese, etc. And this is in the internet as a whole, and basically you looking more or less, among other things, at the language that web pages are written in. And so it's very, very generic, and also estimating based on the population on a given country with internet access, and then looking at the language distribution in that country and trying and doing some smart things. So this gives you an estimate. So you have almost, I think it's 800 million people in English and a little bit, 640 or so in Chinese, etc. Okay. But of course, this is somehow a very skewed perspective as well. Right? This is saying all the people that have access to the internet, we're trying to guess more or less what the language is, and then look at the distribution of languages, and that kind of makes sense. Of course, you can also look at what people are actually typing online, and particularly in Twitter, and then try to, and since we have access to the text, you can also try to get information on what the language is. Of course, there's very sophisticated language detection tools, and you've probably seen something like this. If you use Google Chrome, you go to a website that's written in a page in a language that you don't understand, and that Google knows that you don't understand. And Google will helpfully say, okay, well, this page is written in Catalan, would you like to translate this? And then if you press the translate button, magic happens, and it becomes written in English. And here I used actually the Google page, because that's the easiest. It's usually the easiest page to find in a random language, but of course it works for any language. And this is the same technology that's used in Google Translate, etc. But you can also imagine that inside this little box over here, there's a lot of technology hiding. Right? There's a lot of stuff going on in the background that's looking at the text of the page and figuring out what the language is, and then figuring out how to translate this. Unfortunately, at some point, Google decided that it would be a good thing to have an open source version of Chrome called Chromium, which you probably, if you use Linux, you probably have it installed. And somebody went to all the trouble of digging through the code and actually extracting the little piece of code that does this magic, that looks at the piece of text and tells you what the language is. And this is done basically by looking at the distributions of so how many I's, how many A's, how many B's, etc. are used, and then comparing this with the distribution in known languages, and then you see what is the most likely language. And since it's probabilistic, it also gives you somehow a measure of certainty, like I said. So this library, you give it a tweet, and it will say, okay, I'm 95% sure this is English, 2% sure it's French, and 1% sure it's Portuguese, or maybe something else. Right? So you can impose a threshold on how certain you want to be. Yes?
Is that really true, the statistical analysis, because it even detects the language just from a single phrase, a single sentence,
yes.
words?
It's very robust.
Wouldn't hold.
Huh?
The statistics wouldn't work if you just had a single sentence or a single phrase, and it still works.
It works very well because the way, so the frequencies of letters are very, very specific to the language.
But not if you have even a short phrase of 3-4 words.
Of course, it works better with longer pieces of text, but it also works even with a single phrase. It works because the number, for instance, in a simple English phrase, you will use the letter E a lot more, for example, than you would use in Portuguese, because the E tends to show up there. So, and this, of course, will give you a probabilistic approach. You say this is the closest distribution. And this is, but this is not something that Google created. This is a very old technique. And this was actually developed, I believe, in the beginning of the 20th century to look at cryptographic analysis. So the Allies would receive a list, a sheet of paper with text written in some transformed cryptanalysis.
I would have no doubts with a single phrase.
A single phrase works very well, and I'll hopefully prove to you in a little bit. With just a tweet, it still works because we did many checks, and you can see that. And you'll see that in a second. So actually, to see that, this is where you see that. So this is again our old map of Spain with all the little cities and all the main highways and streets, but this is using all the geolocated signal we have, right? All aggregated over all the period of time. You can of course now ask to each of these tweets which language are you written in, and color it according to the language. And then what you find is something like this. So you find that I believe 68, around 70% or so of tweets are written in Spanish. Actually, I should have put the percentage. Then you have about 80 or so in English, 5 or so in Catalan, and then the rest in Portuguese and Italian, etc. So you can get this aggregation. And you can see also where they are distributed. And of course, you would expect as you expect, Catalan tends to be centered in Catalonia and Madrid, and of course Mallorca.
And Seville.
Huh?
And Seville.
And Sevilla. I didn't see that one over there, but but somehow the geographical patterns that you find here, even on such a small scale, let's say, as Spain, are relatively make sense somehow. You can, of course, also look at the larger scale. And now here what I'm doing is I'm coloring each tweet with a color corresponding to the language. And when you put these things on the map, and you color each tweet with a specific, actually I should have the color legend here, you find the most amazing thing, that people in Spanish speak mostly Spanish, people in France speak mostly French, people in Italy speak mostly Italian, people in the UK speak mostly English. So this somehow convinces me that the library is not just guessing what the language is, it's actually doing something that makes sense. Of course, it's not a scientific finding, it's not telling us anything we don't know, but it's confirming that the approach actually works. Somehow. Or at least it's not doing something completely and obviously wrong, which is already a good thing. And you convince the referees, which is also very good. Of course, there's also these biases. So here what I'm plotting is basically the fraction of tweets which are written in the main language of the country. So, of course, this varies a lot depending on which country you are and how somehow open to the outside world the country is, both being too open and too closed. So, of course, you have US and most of America speaking almost exclusively English and Spanish. In Europe, you have a little bit more of a mix. For instance, Portugal tends to be around 40 or 50% written in Portuguese and the rest in English or something else. China, of course, tends to be mostly English, because if you're in China and you're using Qt, you're breaking the law, so you're trying to get outside the control of doing it in English and not in Chinese.
Which is the language of India?
Which is the language of India, mostly English. Of course, there are many local languages. There is Hindi, there's all those things that we also have to take into account. But if they're trying to reach the outside world, they're speaking mostly English. And English tends to be the more common language that connects everyone. Of course, you can't just use... One of the problems we had when doing this analysis is you can't just use what is the official language of the country. Because some countries don't have official languages, like the US. There is no official American language. Other countries have several languages that nobody uses. Portuguese has 2 official languages, it's Portuguese and Milanese. And there's like 10,000 people who speak Milanese. But it's still an official language, so you have to take it into account. India, of course, has like 50 million official languages, corresponding to the different areas, which of course you can take it all into account, so you have to be a little bit more creative. So, moving on. You can also look within one country, what is the share corresponding to each language. So here I have about 20 different countries. The ranking is just in fraction of English tweets, which is the big black area. Just a quick sample. See the black area, and of course you find the usual things, but you also find so you can see all the distributions, and of course you find Malay in Malay, mostly Malay in Malaysia, but also a lot of English in Portugal, which is hiding somewhere over here. You find a lot of English, but also a fair amount of Portuguese, and Spanish, Italian, etc. And Spain, which is here, you also get a lot. It gets a little bit of Portuguese and a little bit of Italian, and of course Catalan and all those others hiding over there. So you can also try to see, okay, so what is the language ranking? So how prestigious or how common is each language? So this is now somehow a comparison with the plot I showed in the beginning for the entire internet. So the language that people are, the native language of people who are using the internet, and this is the language that people are using on the internet, which is this distinction. Of course, English is the main, and especially in Twitter. And this, of course, English is the main, but then you have Spanish as the second one, Indonesian and Malay is third and fourth, Japanese is fifth, etc. One thing you should also wanted to check is, okay, are we actually measuring something, or is this library still giving us somehow random results? So here what we're doing is we're plotting the same quantity, so the distribution of number of tweets per day, so for each user, so looking at each user, and we're aggregating in different ways. So here we're doing in terms of countries, so we're looking at the distribution of number of tweets per day for each user for the US, for Canada, Germany, France, etc. And you get this somehow broad-tail distribution, which you can call whatever you want, more or less. You can, of course, also aggregate this in languages. So now we're taking the library into account and aggregating this, and you find the same distribution. Or you can pick one specific language and aggregate the countries, and again, you find the same distribution with varying fluctuations corresponding to the sample sizes that you get. But this is what this is showing us, or at least what we claim that this is showing us, is that it's giving us something that corresponds to what we're actually doing, and not just something that's intrinsic to the way we're aggregating the data or analyzing the data. Right? So it's something that, regardless on how you mix it and how you dice it and aggregate it, you always get the same distribution, so it corresponds to something real somehow. Of course, you can look, this is a little bit more of the view of separation between languages within a specific country. So you're looking at the separation between Spanish and Catalan in Catalonia. So you'll find Spanish mostly in Barcelona. Catalan tends to be in the more inland cities, so Girona, Vic, etc. Of course, you can do the same thing in Belgium. So in separating between French and Flemish, and you can clearly see that there is the Flemish part and then there is the French part, and exactly where the boundary is. And this, of course, matches well with more or less what you get from census information, etc. And of course, and just to close this little introduction where I'm somehow trying to convince you that this actually works, what I'm showing you here is a map of Italy that we divided into small cells. For each cell and for each month, I'm basically counting how many tweets not in Italian were made in that cell, in that month. This is averaged over a couple of years. And what this is showing you, again, not very surprisingly, is that people in the summer tend to go to the beach and to roam. People in the winter go to the north and to the mountains, which again is somehow corroborating what you'd expect, that you're seeing patterns that are not only what you expect, but that are also real. So somehow it's again verifying that your approach is correct and valid. So now we can look at something a little bit more serious, and this is actually the stuff I started doing with David last year. It says, okay, now that we have all of these languages, we can identify where each language is and who's speaking it. Can we also look at local variation? Right? This plot is not mine. This is by Joshua Katz, North Carolina State University. And what he did was very simple. He walked around and he asked people questions of this kind. Right? What is your name? What is the word you use to say X? In this case, X is sweetened carbonated beverage. And some people in some places will say soda. So when I'm talking about this, I'll say soda. I want a soda. Some will say pop. Some will say Coke. In Georgia, in particular, everything is Coke because Coca-Cola owns the state. That's where the headquarters of Coca-Cola is over there, more or less.
But in fact, it's more intense in Alabama, Mississippi.
Where?
Than in Georgia.
Here? Yeah, I mean, there's
Georgia
still
is the one that,
this is Georgia.
Alabama, Mississippi,
Yeah, so there's a transition over there somewhere.
Yeah, the Mississippi River is.
Oh, Mississippi is always special. So you can delineate basically these geographical variations of where the different languages are used.
Tennessee.
And so last year, after I gave this talk where I talked about some of these things, David came to my office and said, what if we looked at Spanish dialects, right? How Spanish is actually used around the world? And this question was, okay, so we have this table of synonyms for different words, for different concepts, that we know more or less should be used in that correspond more or less to different dialects of different places. And can we actually look for them in the data and see where they are and try to extract the dialects directly from the data, right? The super dialects. And this actually was very surprisingly successful, and it actually got a lot of press coverage. And this is actually an image I stole from one of the articles that was talking about the paper. So this is what Spanish looks like on Twitter. So as you'd expect, Spanish tends to stay in Latin America and in Spain, with, of course, some things in the Philippines and other places, but mostly where you'd expect it. And then you can start looking, okay, so given all of this data, and in this case we had, I believe, over 50 million tweets that we knew, according to our library that we already checked to make sure everything was okay, that were written in Spanish. We had this list of words for concepts. So here we had words for bus, here we had the words for car. We divide again the world in these little cells. Inside each cell, for each concept, we see what is the word that is most common. Right?
Could you read the ones in yellow?
Oh, sorry. Camioneta and coche.
Okay.
So, and what this means, yeah, I should find better contrast colors. So, and then for each cell, you draw a circle, basically proportional to the number of tweets in that cell, and color it proportional with the color of the dominant word. Right? So what this means is that in this area over here, bus is the dominant word, and in Spain as well, while in here is mostly guagua. Same thing here, so auto tends to be in this lower triangle over here, while carro tends to be more or less everywhere north of there, with small exceptions.
Why do you think in Argentina you don't have any signals, sign for bus or
Huh?
in Argentina you don't have?
Colectivo.
No, it's called micro. Because it's autocar or autobus in Argentina it's called micro. Everybody calls micro to go for long distances. Not autocar, neither bus.
I mean, this was we were not the ones compiling the list. The list came from some linguists in a project called dialects. They were from Harvard, I think. And they basically compiled this list and says this is the list of the dialectical variation of Spanish for a few concepts. And that's what we're trying to find in the data.
There is something interesting here, for example, that in Spain, I would say it's much common to call about autocar and autobus.
Mm-hmm.
But I understand that in Twitter, that you tend to make shorter sentences. Instead of autocar or autobus, you will see just bus because it's shorter. So I think there should be some differences between the dialect in Twitter and the dialect in the street.
Probably. I mean, there is this bias towards trying to shrink things if possible. But you still see even relatively long words like camioneta, for example, in many places. So it's not entirely that the people would choose the shorter word everywhere. So, and then given all of this data, say we have this, basically maps like this for 40 different concepts with I don't know how many words in total. And they say, okay, can we actually extract some type of information from it, some type of geographical pattern? And it's clear, for instance, that in this area, red is dominant. Of course, there are other colors that I'm not showing here because I'm only showing the dominant one. But it's clear that it's dominant here, while camioneta, for example, is dominant in Mexico, there, and bus in these areas over here. So it's obvious that there are some patterns here that are not completely random. Yes?
So a question related to music. So the frequency of the words has no relation to the length of the tweet because they can also change in words, no?
The frequency of the words has no relation to
The length of the words there
yes.
has no relation to the length of the tweet?
I mean, I don't know what the length of the tweet is. I mean, I can measure it, I didn't measure.
In the same
Okay.
tweet,
In the
you mentioned bus 3 times. In the same tweet.
You could. I would only count it as once.
I don't know what you mean.
I mean, you can type bus 3 times, but I would only count that as one.
No, but I mean, it's 140
Characters, yes.
characters, right? So maybe if I only want to say 2 words, I'll use a long word. But if I want to fill that, I'll use
Yeah.
bus.
Yes.
So how do you...
I have not checked the correlation with the okay, so can we extract some type of geographic information from this? Of course, the way to do this is you try to do some type of machine learning approach. Right? So you feed all of this data into a computer, and you tell the computer, find me patterns. And the computer will crank things, and you say, okay, find me 2. And if you say, find me 2 clusters, and it will find you 2 clusters, whatever the best fit for those clusters. If you want to find me 3 clusters, then you find me 3 clusters. That's it. And they can do, of course, you can keep doing this forever. You can find me 100 clusters, and it will find you 100 clusters. But then, of course, you have to figure out a way of seeing what is the best number of clusters. Right? And that's where these 2 things come in. So you there are many metrics to do this. We chose 2 just to check that they agreed. This is called the F of K statistic, which is, of course, is a very original name because it's represented as F of K. And the silhouette, which basically tells you how far and how well defined the clusters are. And here you are looking for the minimum, and here you are looking for the maximum, and of course they agree too. So what this means is that if you just look at the full raw data, and you run this well-tested machine learning algorithms, you should find 2 clusters, and then you identify the clusters. You look further, and you say, okay, I know I have a bunch of cells. I know what cluster each cell belongs to. Here, actually I'm missing the legend over there. I'm showing you for the 2 clusters which I'm calling alpha and beta, or the 2 super dialects, as you like to call them. I'm showing you here is the population. So this is 8 times 10 to the 6. 10 to the 6, I think, yes. So the population distribution in each cluster. So these are called box plots. This thick bar over here gives you the median. The variation in this box basically tells you the difference between the 25th percentile and the 75th percentile, and then that gives you the variation. And you see something immediately. Right?
Sorry, what is the distribution of what?
Of the population in the cells belonging to each cluster. Right? So what this is showing you is that even though this cluster here has only 179 cells, it actually corresponds to cells that are much more populated than these clusters. So these somehow are the cities, and these are the less city areas, more rural areas, if you want. And indeed, when you put this thing on the map, and you color each cell with the color corresponding to the cluster, you will find that all the major cities are red, and areas outside the major cities are blue.
The cells are defined by a given size or by a given number of tweets in each cell?
No, the cell is defined. It's a grid that you overimpose it. It's a Cartesian.
So it could be cells that has many tweets and cells which has very few tweets.
Yes, and this is exactly. Yes. So because the tweets also correlate somehow to the population. Here I'm normalizing for all of that, so I'm not giving more weight to cells that have more tweets, and less weight so I have the tweets. I'm taking all the cells the same, and I'm just looking for similarities between the cells. And that's how we're defining that's what the k-means algorithm, which is what the machine learning algorithm I'm using, is actually dealing with. It's not actually dealing with the raw number of tweets. And I said what you find is basically you find these 2 big super dialects, which are called the city Spanish and the rural Spanish, in a very funny way of saying it. So because you find it immediately that it is more or less in all the major cities. So you have San Diego. So all the cities that you see listed here correspond to a red cell.
But this is without distinguishing between the words in Europe or North America or whatever. So I mean, if in Spain everybody uses bus, and in Mexico everybody uses camioneta, for instance, this classification does not apply. I mean, in the sense that for that word, the first classification would be bus and camioneta.
Yes, but for the other words, they will be much similar. It means that the red cells are much more similar to each other than they are to the blue cells.
Yeah, but what I mean is that camioneta is more similar to camioneta than to bus for any bus in Spain.
By definition, yes.
So how it could be that the camioneta in the center of Mexico and the camioneta outside the center is so different, is much more different than camioneta with the bus in Madrid?
Because this is not looking just at camioneta, it's looking at all of them. So for camioneta, maybe it's the same everywhere, but for other words, maybe it's different in some places than others. And then when you compare mathematically all of these things together, you find the similarities. So basically in a very simple way, what this is doing is it's looking for clusters in this space.
So what you mean is that statistically,
yes,
the main words that are used to characterize the difference between the Spanish in Spain and the Spanish in Mexico, or the Spanish in the Caribbean, which would be camioneta, cart, and all that, statistically are very few. And other words, which are the same here and there, but have different use in the cities and outside, are statistically more relevant. Because if everybody were using these words that are different here and there, statistically, the cluster couldn't appear in this way.
I'm not sure I understand the question. No, I missed something.
What you say is that you take all the words and you put that on a black box and say, what are the clusters? And
Yes.
you see city and outside.
Yes.
Now, I'm saying, if all the words were like bus and camioneta,
If all the words,
words
yes.
in Spanish were like bus and camioneta, that there is a word in Spain and a different word in Mexico, the cluster would be not that one. Would be a cluster in Spain and another in Mexico. I'm simplifying.
Yes. Yeah. And you will see
The
that
fact
also.
that this does not appear means that statistically, the words that we always use to distinguish the languages, like the camioneta versus bus, or coche versus carro, and so on, are statistically not so many. Because if the dominants were by these words that are different in Spain and America, then the cluster would have been Spain and America.
No, but there is another thing is that he was showing the majority word, but the others they are also
Yeah,
there.
they are also there.
That's what I mean, but statistically, the words that are used are not these ones that are different.
No, this can be true. But for instance, in Spain, can be people call it camioneta, and he was showing just the color of the most used word.
Yeah, but
so there is a
still,
fraction.
but it's very few people who call camioneta bus.
Well, I mean, we have a lot of immigrants from different places, so in some cities you may have more mixing.
But even though, I mean, this means that basically the words that is the point is that the words that we usually use to characterize the difference between the Spanish in Spain and the Spanish in South America are a minority of words when you think the words that are used in number one.
More common words.
We have much more common words than words that are different.
No, of course. I mean, otherwise it wouldn't be the same language.
No, but
But you are comparing only you are only comparing not on the language, not on the word. You are only comparing words which are different in different places.
I'm comparing this list of 40. So for these 40 concepts.
40 concepts which are used different words in different places.
That use different where you have the choice of different words that are equivalent, and these words tend to be used differently in different places. And this, again, this data set was compiled by these linguists, dialects, specifically to characterize the clusters, to characterize dialects. Using that, you can get these patterns. And this is the first layer of patterns. There is more to come. So here, what I'm showing is that the Spanish that is spoken in cities tends to be more similar to other cities than to rural areas, while the Spanish in rural areas tends to be more similar to other rural areas than to the one in the city.
But I mean, going with what he was saying, this essentially can be a signal of that in the big cities you have mixing of the
Yes.
different immigration,
Yes.
while in the rural areas you have uniformity in
Yes,
the concepts.
and this is precisely the way we interpret this is that in the city somehow what you get is a mix of everything, while in the rural areas you have more variations. And in fact, we're going to see that right now. So here what we did is, because we had the cluster, we had one cluster that was 150 or 170, whatever it was, and the other one was 900 and something. I said, okay, let's look at this big cluster, which corresponds to the rural areas, and let's see if we can split it down more. See if we can find more structure in the data. And when you do that, then you find a lot more clusters. So you find the Spanish cluster, you find like the central North-South America cluster, and then you find the South America cluster. And a couple of others that are more scattered out. So what this means is that, yes, there is a lot of structure, but there's also, that is geographical, but there's also this distinction between the city areas and the rural areas. And that's why they're called super dialects, because they're not it's not a dialect that is in the contiguous area. So it's something that's more abrangent, let's say. I'm not sure that that's a real word in English, but you know what I mean. Right? And of course, this popped up, we posted this in the archive just before the vacation, and everybody went crazy. And we even had contacts from linguists saying it was a very good work, and it was quite very interesting things. And showing support, of course. I'm sure there were people insulting us somewhere, but we didn't. Not loud enough that we would hear. So. And this is still under review, so hopefully it will come out at some point soon. So moving on. Now another thing you can do is say, okay, now we've looked at one language in detail and found the structure. Can we also look at the connections between languages? Right? So here what I'm showing you is a network of of languages. So each dot is one different language, corresponding to different family, and I'm coloring the nodes proportional to the family. The size of the dots is proportional to the population that speaks that language, etc. And I'm connecting the languages basically based on the number of common speakers. So this thick edge over here means that there is a lot of people that speak English and Spanish at the same time, or that speak Malay and English, etc. So this corresponds somehow, it's a network of influence between languages. And the idea here is that if one person speaks two languages, this somehow acts as a bridge between these two languages. This person can receive information from one language and spread it in another language if he wants, and somehow counts as a cultural influence from one language to the other. You seem unconvinced.
No. I'm thinking of a question of some links. I mean, I would be one in speaking Spanish and English.
Yes.
But I will never be called a bilingual by a linguist.
I mean, for me, a bilingual is someone who speaks two languages.
Yeah,
It's not a bilingual in the sense of someone that grew up speaking two languages and can speak them interchangeably completely. This is just
so
someone.
here are just people that are able to speak fluently the two languages.
Yes. So here in particular is people that can tweet in two languages. You can, of course, because Twitter is Twitter, and there are the biases we know of. You can also look at people who edit Wikipedia in two languages, and this is probably a lot closer to the more traditional, more fluent way of looking at languages. And you see that the structure remains overall the same, with some variations, of course. And you find the clusters that you would expect to find, also in Twitter, so you find, which I can't actually read. So you find like the Russian cluster with all the Russian languages, English, and then somewhere there is the Latin cluster, etc. And of course, you can, if you want to go even further away, completely away from the internet and from these things, you can look at book translations. Right? And again, here we're bringing a little bit more towards the cultural influences. And what this is showing is exactly the same thing, but now is using a database from the United Nations that says this edition of this book that was originally published in Russian, so the 1800 edition of Anna Karenina was translated by this guy into Spanish. Right? And to this edition of this year in Spanish. And then let's say a few years later, somebody translated that specific edition of Spanish, Anna Karenina, into Catalan Anna Karenina. Right? And so you can see how the influence is spreading, and you can do the same thing and generate another network. So we call these the global language network. So the network of how languages influence each other, and somehow as a proxy of how these cultures are influencing each other. Of course, now what we have here are three different networks that somehow should correspond more or less to the same thing. So you should look for correlations between them. In particular, here we go. So here we have the correlation between, so this is the weights on the edges of these three networks for the network of Wikipedia versus the network of translations, and you're looking for correlations between the weights. And you say, are these networks, do the networks look statistically the same? So you find about 63% agreement. For Twitter and books, the agreement is a little bit less, it's 40, because also Twitter is not books. And between Twitter and Wikipedia, you get around 66%. So somehow, this is giving you some information that you're actually getting something useful out of this, and it's actually corresponding to some underlying structure. And that hopefully is giving you some information about the way the languages are actually interacting with each other. And actually, here I won't talk about it much more, but in this paper we actually go take this actually collaboration with Cesare Dao in MIT and Steven Pinker in Harvard, and we actually take this more towards the cultural influence side, and we look at number of famous people in one language and another language, and measure all of these things in a much more detailed way. Here I'm just talking about languages, so I'll focus more on this. And moving on, now we can say, okay, so now we saw one language first we saw that we can actually identify languages and see what languages are spoken around the world and when. We saw we can actually pick one of these languages and look at it in detail and find the dialects in the structure. We saw, hopefully, I've been able to convince you, that somehow we can actually see how the languages are interconnected to each other through these bilinguals or people that are fluent in more than one language. Bilingual is just a much shorter way of saying it. It sounds better to me. Anyway, it's not the correct scientific term. And another thing you can say is, okay, but now we have all of this information on Twitter. And people are posting these things. And then when you see someone post something, you can compress a little button and you can reply to them. So you can have these conversations on Twitter. You can have people talking to each other. So now you can actually look at how people are talking to each other. So you can actually observe conversations in real time somehow and see how people are actually behaving. But then, of course, you have this, whenever you have conversations between people that potentially talk more than one language, you have this problem. Right? You have to agree on what the language is. So this is a tourist arriving in Taiwan and asking to speak English because she doesn't speak Chinese. Right? And the reason, of course, why people don't usually learn Chinese is because everybody speaks English. Which, of course, you see in this plot that we already saw a little bit before now in the computer. Is this making noise? Sorry. Right? So we can look at these conversations and see what language people are talking. So I'm not really interested in what they're actually saying. I'm interested in the language that they are using when they talk to each other. So I gather from, now ignoring the geolocation part, so I'm not looking just for GPS, I'm looking at the whole thing. With Jose, last year, we started this last year when I was here, saying, okay, let's grab 1 billion tweets, extract all the conversations out of these, and we have about 400 million or so edges in these conversation trees that correspond to conversations somehow. Let's look at the structure of these things. So of course, now what we have is instead of just conversations, you actually have conversation in specific languages.
Have you looked at, or do you know, if it is in number sense significant, the number of conversations which are in 2 languages?
The number in conversations in 2 languages. For yes and no. I mean, yes, and I think I know what you're asking. What we did look,
which here could be common, is that someone talks to me in Catalan and I reply in Spanish.
Yes. I did not look for this specifically in one conversation. I looked at number of languages used per pair of person. And that you have a distribution of languages. So most of them are, of course, is 1 language, sometimes 2, sometimes 3. You get like this exponential decay, which I will show that in a little bit. I never looked specifically for one conversation, like one tree.
No, to have an idea of how many conversations in a place are in two languages.
That I know how many pairs of people talk to each other in 2 languages, yes. And how many talk in 3 languages and 4 languages. I'll show you that in a second. So you get these things, and you can, of course, and of course, the idea now is, okay, now you can look at these things. So you can